Okay, so another thing we're going to have to look at is going from a worded equation here into a chemical equation. So we have magnesium hydroxide plus potassium chloride gives me magnesium chloride plus potassium hydroxide. I have no idea, kids, and I know it must be irritating, but I have no idea why I can't draw it in a straight line. But it's all right. This is hydroxide over here. It's just come off the side of the page. So we need to go from words to symbols. So first, let's put the symbols in. So magnesium is Mg, and hydroxide is OH, and you can of course find that on your valency table. And then over here, potassium is a K and chlorine is a Cl. Now that over here, of course, makes magnesium Mg and chloride Cl plus potassium and hydroxide. So I've managed to put them from words to symbols, but one of the problems is, have I actually combined them correctly? And this is where your valency table comes in and where you actually need to have a look at these things. So let's have a look at magnesium. It's a +2 ion, and that means it's got 2 electrons that it wants to give away. And we have a look at hydroxide, of course, it's a -1 ion, which means it only has one space. Now we have a problem here. You need to get rid of 2 electrons and only one place to put them. So we would put 1 in there, and then of course we would have to grab another hydroxide here, and that would put that electron in there. So we have 1 magnesium, good, but we have 2 hydroxides. Now we need to be careful because hydroxide is a polyatomic. It's got 2 capitals, so it's got an oxygen and a hydrogen. So in this case, we need to put a bracket, and we need to put a bracket and a 2 there. Because if I just go, well, okay, I need 2 of them, the problem is there's 2 oxygens here and there's 2 hydrogens, but here it only represents 2 hydrogens and 1 oxygen, and we know that's not true, so we can't represent it that way. If we look at potassium and chloride, well, potassium is a 1+ ion, so it has 1 electron to give away, and chloride being a -1 ion, and then it has 1 space. So, oh, look at that. They fit perfectly. Brilliant. So we don't have to do anything around that. We don't have to change it or anything along those lines. For magnesium chloride, let's have a look at that. Well, we already know that magnesium is a 2+ ion, so it has 2 electrons, and chloride is a -1 ion, so it has 1 space. So put 1 in there, means we'll need another of these chlorines, so we have to put a 2 there. And if we go back and have a look at this, we've got our +1 potassium ion and our OH -1. So once again, 1 electron for 1 spot. They fit perfectly. Everything is funky-dory. Now, once we've done that, of course, the problem is this balanced? Well, we can clearly see that it's not, because we've got 2 chlorines here and only 1 there. So the first thing I'm going to do is put a 2 there, and that will give me 2 potassiums and 2 chlorides. So since I've got 2 potassiums, well, I'm going to have to put a 2 here to balance out the 2 potassiums on this side with the 2 potassiums on this side. But will also give me 2 hydroxides, but that's okay, because I already have 2 hydroxides here, and as we can see, that has balanced my equation. So let's say that's going from a worded equation down here to a chemical equation. Let's say we have something along the lines of this though. Let's say we'll do a different type of equation. We might come up a little bit. Let's say we've got Ag plus CuSO4. And that's going to give us AgSO4, there's a 2 there, plus copper. Plus Cu, should I say. Because if we're going to go from a worded to a chemical, we might as well go from a chemical to a worded. So first off, we just need to know what Ag is, and of course, Ag stands for silver. We could find this in either our periodic table or our valency table. And then CuSO4. Well, I know that Cu is copper. And if we look at our valency table, we'll find that SO4 is a sulfate. Now, sometimes you'll see it spelled PH, or sometimes you'll see it spelled F. And over here, well, I've got silver, and I've got this sulfate, and of course, I've got copper by itself. Now, this, of course, would be a single displacement reaction. This one up here was a double displacement. But this would be a single displacement, and I've managed to go from a worded chemical to a worded, or from a worded to a chemical equation. And that was the purpose of this video. Hope that helped. Remember, use your valency table, use your periodic table. Okay, see you later, kids. Still can't find my purple texter.